Hi guys, what's up? Welcome back to my CAT tutorial channel. Daniel's here and today I'll be talking about financial mathematics and exam FM preparation. You know, financial mathematics is an area that deals with money, interest, and investment. So when you invest your money, you really care about interest, how to maximize your benefits. So we need a tool to measure the interest and to compare the interest. Suppose you are planning to invest your money into different options and you don't know which option will give you the best benefit. In that case, you need a tool to measure the interest, to compare and see which option will be the best benefit. So that is the purpose of our lesson today. Lesson 1, measurement of interest. So when you invest your money, in general, your future money, suppose you invest $5,000 today, and the saving account earning interest at effective rate of 5% per year. So after 1 year, your money will be accumulated at a rate of 5,000 times 1.05. After 2 years, that amount will be multiplied with another 1.05. So you see that your accumulated value or the future value basically depends on two things. The first thing is the principal, that means the money that you invested at the beginning, and it also depends on time. So that's why in financial mathematics, the general financial model to make connection between the money you have in the future with the money you invested today is FV equal to P times AT, or AV equal to PV times AT, where FV here is the future value is the same as AV. So it's a difference. Sometimes people call sometimes people use FV and sometimes people use AV. So AV is the accumulated value at time t. P is the principal, or just basically how much you invested at the beginning, or if you get in a loan, how much you get at the beginning. That means P represents for the money at the initial time. And for sure, because as I said, like future value, accumulated value depends on time. So we will have AV is PV time with a function of t, and that function here I notated by AT. AT is the accumulation function which depends on time t. So today we will go over some main points. That is, the first thing we will go over today is accumulation function. We will be considering some definition, some basic concept in accumulation function. And then we will have effective rate of interest and discount, simple interest, compound interest, nominal interest rate, nominal discount rate, force of interest rate, power series, evaluate present value and accumulated value, and how money invested at an arbitrary time works. So let's start with the first point, accumulation function. So first definition. Please let's look at this formula again. So AV is PV times AT. You see that, suppose at the beginning you invest only $1. Suppose you invest only $1. Then you see that the accumulated value is 1 times AT, that is exactly AT. So basically AT is a function of T. So basically accumulation function. Definition 1. Accumulation function is a function of t, a function of time t that measure the accumulated value of $1 invested at the beginning, or at initial time, at the initial time. And accumulated function is accumulation function is notated as AT, A of t. A of t. So here, since the function is depend on t, so we will have many type of AT. For example, sometimes you might have a function AT. Let me show you some graph, the graph of AT. So sometimes you might have the function AT that is basically a straight line. That means like no interest. For example, you borrow money from your uncle or your relatives, and you should promise to pay back money at a certain time. But because they are your relative, they are your friends, so they do not take interest. So in this case, AT is just a function, a constant function of 1. So AT here is just a straight line, a horizontal line. In this case, we call this accumulation function is a representation for biggie bank. That means a loan from father-in-law. So that's why you don't have to pay for interest. Another case, like money will go by a straight line. This is a linear line. So in this case, we call interest invested a simple interest rate, and I'll go over simple interest rate later. Sometimes the interest rate will be like the accumulation function will look like this. So we have many type of accumulation function. So that is the first definition, accumulation function. Okay, now we go to the second thing that then what is the definition of future value? Definition 2. Future value or accumulated value. Accumulated value is the amount of fund you have when you invest a fund that accumulated from a fund of P dollars. And definition 3 present value is how much money you need to invest to attain accumulated value, attain an accumulated value, attemptee. So that is about accumulation function future value or accumulated value or present value. And present value is usually notated by PV. And future value is usually notated by FV. Now we are going to effective rate of interest and effective rate of discount. So effective first 2.1 effective rate of interest. Effective rate of interest. Suppose your accumulation function look like this shape. So here suppose this is at the time t minus 1 and this is at the time t. So the effective rate of interest basically measure the rate of change of the accumulation function based on the fund at the beginning. So effective rate of interest measure the rate of growth based on the fund at the beginning. And simultaneously we have I'm sorry, I'm doing a mess here. Okay, and simultaneously we consider another rate is called effective rate of discount. Effective rate of discount. So effective rate of discount is measure the rate of growth based on the fund at the end of time of the year, the end of the year. And the formula to compute the effective rate of interest is IT equal to A of t minus AT over A of t minus 1, because that is the rate of that's measure how much the money grow based on the beginning of the year. And similarly, we have effective rate of discount is dt equal to at minus a of t minus 1 over a of t. See that? So we have two rates here, effective rate of interest and effective rate of discount. Okay, next we will be and from the first formulas we have at is equal to a of t minus 1 plus it time with a of t minus 1. And we have a of t is the same as a of t minus 1 time with 1 plus it. And from the second formulas, we have a of t minus 1 equal to at minus at times with dt. So a of t minus 1 equal to a of t times with 1 minus dt. Or a of t equal to a of t minus 1 times with 1 minus dt to the negative 1. So now we have two more formulas how the accumulated value is computed based on effective rates of interest and is effective rates of discount. Now we go to the next thing, that is simple interest and compound interest. 3.1 Simple interest. In simple interest, accumulated function is a fund is said to be credited at simple interest if the accumulation function is a linear function of t as below. So I'm going to insert formulas. That is a of t equal to 1 plus IT. And in simple interest, the effective rate is calculated as, we have I1 is equal to A1 minus A0 over A of 0. And that's equal to A1 is 1 plus T minus 1 over 1. And that's equal to 1 plus I. That's equal to I. I of 2 equal to A of 2 minus A of 1 over A of 1. So that's equal to 1 plus 2I minus 1 over 1 plus 2I minus 1 plus I over 1 plus I. And that's equal to I over 1 plus I. And so on. Next, we have compound interest. Compound interest. Compound interest. A fund is said to be credited at compound interest if the accumulation function is as A of t equal to 1 plus I to the t. So that is about simple interest and compound interest. And in financial mathematics, we are basically just consider simple interest and compound interest. Next, nominal interest rate and nominal discount rate. So first 4.1 nominal interest rates. Nominal interest rate. First, nominal interest rate. A fund is said to be accumulated, to be credited at a nominal interest rate compounded of I of of I per year compounded in time per years if A of t equal to 1 plus I m over m, the whole thing raised to the m times t, m times t. This is I m. So we have relation. Notice there is a relation between the nominal interest rate, the nominal interest rate, the nominal interest rate, IM, and the effective rate, I. So you know that AT is one plus IM, I to the top M over M, the whole thing raised to MT, and AT is also equal to 1 plus I to the T. So from here, we will solve for IM respect to I. So we have 1 plus I to the group M over M equal to 1 plus I to the power is 1 over M. So I to the top M is equal to M times with 1 plus I to the 1 over M minus 1. So this is the connection between nominal interest rate and effective rate. Next, nominal discount rate. So similar to nominal interest rates, we also have nominal discount rate. So a fund is set to be credited at a nominal discount rate, effective rate of discount d to the script of m if compounded discount rate per year per annum compounded m times per years if d to the if at is accumulated by formulas 1 minus d m over m, the whole thing raised to the powers negative of mt, and a connection. Notice there is a relation between the nominal effective rate of discount and the nominal and this is the nominal rate and the effective rate. This is nominal rate and the nominal and the effective rate of discount. So we know that AT is equal to 1 minus d to m over m, the whole thing to the nib mt, and this is equal to 1 minus d to negative t. So from here we will solve for d with the top script m. So 1 minus d top script m over m equal to 1 minus d to the powers 1 over m. So d to the top script m is equal to m times with 1 minus d to the powers 1 over m. So this is a relation between the nominal rate of discount and the effective rate of discount. And also we have 3.3 relation between interest rate and discount rate. Interest rate and discount rate. So we have AT is equal to 1 plus I to the t, and this equal to 1 minus d to the negative t. So from here we have 1 plus I equal to 1 minus d to the nib 1, or basically it's just 1 over 1 minus d. So we have I, or 1 minus d equal to 1 over 1 plus I, and this 1 over 1 plus I, I'm gonna call this is V. So 1 minus d is basically equal to v, and we have d equal to 1 minus v. And 1 minus v here is 1 minus 1 over 1 plus I. 1 plus I. 1 plus I. And this equal to 1 plus I minus 1 over 1 plus I. So this is equal to I over 1 plus I. So this is how you make connection between discount rate and effective rate. Next, we will consider the force of interest rate. So, why do we need the force of interest rate? Suppose we compare between two accumulation function. One accumulation function show up like this and then increase by a constant rate. And the second function also go like this is the shape of two different accumulation function. Let's say this is time t. So you see that if you compare between these two accumulation function at time t, using the effective rate and discount rate, these two functions basically give the same effective rate and discount rate. So in this case, you make a conclusion that these two accumulation functions are the same, but actually if you look at the whole graph, they are not the same. So that means in some cases, effective rates and discount rates are not enough to compare between two accumulation functions. And at that time, we need another rate that is called force of interest rate. So here the force of interest rate is notated by, so here the force of interest rate, the force of interest rate, the force of interest rate, notated by delta t, notated by delta t. Measure the rate of change of the derivative of the accumulation function. And the force of interest rate is computed as delta t equal to a prime of t. That means the derivative of accumulation function over a of t. Or by differentiate notation, that become d over dt of at over at. And this is basically by chain rule. This is d over dt of natural log of at. So this is how the force of interest rates computed. So that is the if you are given the function if you are given the accumulation function, it's easy for you to compute the effective rate, the force of each effective rate delta t. However, in some cases, you are given the force of interest rate of delta t, and you are asked to find the function accumulation function at. So we have the reverse problem. reverse problem. Reverse problem. That is given the force of interest rate delta t force of interest rate delta t. How to construct the accumulation function, So here's the thing. When you are given the accumulation function and you are asked to find the force of interest rate, all you need to do is take the derivative. So for the reverse problem, when you are given the force of interest rate and you are asked to find the accumulation function AT, this problem we need something called antiderivative. So that means our solution would be antiderivative. So here I'm going to take the derivative both sides, because here delta t is the derivative of natural log of AT. So if I take the integration both sides, I will have AT is a function in terms of delta t. So I take so I integrate both sides. Integrating integrate both sides of the equation of the above equation and because we consider on the interval from 0 to t, so on the interval from 0 to t, what we have here is integral from 0 to t. One second. Integral from 0 to t. Okay, from 0 to t. And because you integral from 0 to t, so delta t, I need to change variables. So that becomes delta of r dr. This is equal to integral from 0 to t of d over dr of ln natural log of ar dr. So we are going to do integration here. The left hand side we keep it the same, so that is integrate from 0 to t of delta r dr equal to, here we have integrate of differentiation, so it's calculate antiderivative, so that become ln of ar go from r go from 0 to t r equal to t, and this is equal to natural log of at minus natural log of a0 and don't forget natural a0 is 1, A0 is 1, because that is how much the money you accumulated at time 1 when you invest $1. At time 0, you invest $1, you have exactly $1. So that's equal to natural log of AT. So how do you find AT in terms of delta of the force of effective rate? We take exponential both sides. So we have AT is basically e to the integrate from 0 to t of delta r dr. So this is the formulas for finding the accumulation function given the effective rate. Okay, so that is about force of interest rates. And we have one more thing. Notice. Excuse me. Notice. One thing we need to notice. In case the effective rate is a constant, that means delta t is a constant number. Let's say delta. That means this is a constant. We have AT, A of t is e to the powers of integrate from 0 to t of delta dr, and that is equal to e to the powers of delta t. See that? So this is how you calculate the accumulation function based on the force of interest rates. And now we are going to make connection between the effective rate, the effective rate of interest, the effective rate of discount, and the nominal rates of interest, the nominal rates of discount with the force of interest rate. So next, connection between force of interest rate and other rates. So the first connection, I'm going to say A, relation between the force of interest rate and the effective rate of interest. So for A, we go over, we know that AT equal to 1 plus I to the t, where I is the effective rate, and this is equal to e to the power of delta t. So leading to 1 plus I equal to e to the delta. So we have delta is equal to natural log of 1 plus I. That is the first connection. So the force of interest rate is natural log of 1 plus the effective rate. Next, relation between the force of interest rate and the effective rate of discount. C would be the another type relation. So for this one, we start with A of t equal to 1 minus d to the powers of negative t. And this equal to e to the power of delta t. So we have 1 minus d inverse equal to e to the t, e to delta. So from here we have delta is natural log of 1 minus d, 1 minus d, the whole thing to the negative 1, and use power rule. We bring negative side to the front, so that is minus of natural log of 1 minus d. So this is the second connection. See that? Next, relation between the force of interest rate and the effective rate and the nominal rate, the nominal rate of interest. So we know that I to the m to the top script m equal to m times with 1 plus I to the power is 1 over m minus 1. And this equal to 1 plus I to the 1 over m minus 1 over 1 over m. So we are going to consider the limit. Of this ratio. So limit, we have limit when m go to infinity of I to the m. Here we are going to use L'Hospital rule. That's equal to limit m go to infinity. Use L'Hospital rule, so we take the derivative on the top and the derivative at the bottom. At the bottom it's just negative 1 over m squared, and on the top this become so this equal to, this is a to the 1 over m, so that becomes negative 1 over m whole square times with 1 plus I to the 1 over m times with natural log of 1 plus I. Natural log of 1 plus I. And this will be equal to limit of m go to infinity of nib 1 over m squared cancel nib 1 over m squared. So this becomes 1 plus I to the 1 over m times with natural log of 1 plus I. And when m go to infinity, 1 plus I to the 1 over m go to 0. So this is equal to natural log of 1 plus I, and which is exactly delta. So you see that the limit of the nominal rate when m go to infinity is the nominal rate, is the force of interest rate. Number 6, we are talking about some power series. So we have two power series here is e to the x equal to 1 plus e to the x equal to 1 plus, let me see, 1 plus x squared. This power series can be proved by Taylor expansion or Maclaurin expansion. 2 factorial plus x cubed over 3 factorial plus ... So this is the first expansion. And we have one more, that is natural log of 1 plus x equal to x minus x squared over 2 plus 2 factorial over plus x cubed over 3 factorial and minus the second series we have alternating sign. And next we have evaluate present value and accumulated value. So first present value, first accumulated value. We have AV is equal to A0. That means the principal, how much you invested at the time 0, time with AT. And this equal to, if you are using effective rate of interest, this is equal to A0 time with 1 plus I to the t, and this is called the effective rates. If you use effective rates of discount, that becomes A0 times with 1 minus d to the nib t. If you use nominal rate of interest, this becomes A of 0 times with 1 plus im I to the top script m over m, I to the m over m, the whole thing raised to mt. If you use nominal rate of discount, this becomes A0 times with 1 minus d to the top group m over m, the whole thing raised to negative mt. And this equal to, and if you use effective rate, that become a times 0 times with e to the powers of integrate from 0 to t of delta r dr. And if you are using constant force of interest rate, this becomes a0 of e to the powers of delta t. So that is how you compute the accumulated value. Now we are working with present value. So present value. Before we work on present value, I would like to include one formula here. That is v equal to 1 over 1 plus I. Let's say that 1 plus I. So we have present value equal to future value. That is, let's say we want to have a at the same time t over at. So if you are this is at over at, and if you are using effective rate of interest, that become a of t over 1 plus I to the t. And because 1 over 1 plus I is v, so this is equal to a of t, capital A of t, times with v to the t. If you are using nominal rate, so v equal to 1 over 1 plus I, and this is the same as 1 minus d. So at is present value is also equal to capital A of t times with 1 minus d to the t. If you are using nominal interest rate, this is equal to 8 of t times with 1 plus over 1 plus I to the m over m, the whole thing raised to mt, or this is equal to a of t times with 1 plus I to the m in the top script over m, the whole thing to the power is negative mt. And this equal to 8 of t times with 1 minus d to the top group m over m to the powers of mt. So by the way, 1 minus d equal to 1 over 1 plus I to the top group m over m, the whole thing to the power mt, and this equal to 1 plus I to the m over m, the whole thing to the powers of negative mt, and this is equal to 1 minus d to the top group m over m, the whole thing to the powers of mt. So that's how you compute present value using effective rate and nominal rate. Now by using for interest rate, this is equal to AT, A of t over e to the powers of integrate from 0 to t of delta r dr, and this is equal to a of t times with e to the powers of integrate from 0 to t of delta r dr. If you are using constants force of interest rate, this is equal to 8 of t times with e to the power of negative delta t. So this is how you compute the present value. Depending on what is given on the question, you decide which rate you need to use. So if the question gives you effective rate, you use effective rate formulas. If the question gives you nominal interest rate, you use nominal interest rate formulas. If the question gives you the force of interest rate, you go ahead and use force of interest rate. So now we go to the last topics of today, that is money invested at an arbitrary time. So from the beginning up to now, we've been working on the case where money is invested at time 0. Now my question is, what if the money is not invested at time 0? Suppose this is the time scale. This is 0, 1. This is represent for time. Suppose you invested $1 at time 1, not 0, and the question asks you for money you get at time 2. So how do you compute the accumulated value? So here we have one simple sentence that say accumulated value of at time t2 of $1 invested at time t1 is AV equal to e to the powers of integrate from T1 to T2. So integrate from T1 to T2 of delta R dr. So this is how we compute the average, accumulated values of $1 invested at time t1, not at time 0. And this is equal to 8 of t2 over a of t1. So please keep this in mind, because on the question you might be trapped by some question that money is actually invested at an arbitrary time, not at the beginning. So that is everything about financial mathematics. Now we are going over some assignments. So today we have go over some accumulation function, effective rate of interest, effective rate of discounts, nominal rate of interest, nominal rates of discount, force of interest rate, how to compute accumulated value, how to compute present value, how to evaluate value that invested at different time. Now we are going to work on some problem. The first problem: money accumulates in a fund at an effective annual interest rate. You see here. So I'm a make it bold. So make it I'm a highlighted. So effective annual interest rate during the first 5 years, and an effective annual rate. You see that? So they want you to use effective annual rate. And it said a deposit of 1 is made into the fund at time 0 is accumulated to 3.09 at the end of 10 years and 13.62 at the end of 12 years. What is the value of deposit at the end of 7 years? So the question, what does the question give you? The question, so basically the first step, we need to pick up information and convert it to notation, what I call mathematical modeling. So I'm gonna look at the question and pick up information to convert into the notation. Here the question said like a deposit of 1 is made into the fund of time 0. So the accumulated value would be just simply a of t. We don't need to multiply a principal in the front, right? And it said is accumulates 3.0 at the end of 10 years. So the first information we have here is a of 10. Accumulation function at time 10 equal to 3.09. And accumulating function of 20 equal to 13.62. And the question asks for a of 7, right? A of 7. And also the question gives you money accumulates in the fund at effective rate of interest rate I during the first 5 years and annual rate of 2i thereafter. So now we are using that information to construct the formulas for A10 and A20. We have A10 equal to 1 plus I to the powers 5, because the first 5 years it is credited by effective rate of I, and the year after, the effective annual rate is 2i. So the last 5 years you have 1 plus 2i to the powers of 5. You see it, to the power of 5. That is the first information. And also we have similar, we have a of 20 is 1 plus I to the power of 5 to the power of 5. And the last 15 years is credited by annual effective rate of 1 up to I. So 1 plus 2i to the powers of 20 subtract 5 is 15. You see that? So A10 is 3.09 and 3.09, and This is equal to 13.62. 13.62. So I is not given. Our job is first find I, and then we can find A of 7, because A of 7 is 1 plus I to the power of 5 times with 1 plus 2I to the power of 2, because the first 5 years is credited by annual effective rate of I, and the last 2 years is 2I. So A of 7 is 1 plus I to the 5th times with 1 plus 2I squared. So our job is find I. Our job is first find I, then we can find A7. So you look at the first two equations. If you divide the second equation by the first equation, on the left hand side you should have 1 plus 2I to the power 10, and the right hand side is just a number, and you will be able to find I, right? You will be able to find I. So here we have 3.09. We have 13.62 over 3.09 equal to 1 plus 2I to the powers of 10, right? So from here we can find I. So I equal to, I'm going to use my calculator, 13.62 divided by 3.09, then the whole thing raised to the power of 1 divided by 10, and then subtract 1 times 2, divide by 2. So I is 0.07995, and we are going to use this to find A of 7. So A of 7 equal to 1 plus n to the powers 5 times with 1 plus 2 times n to the power of 2. So A7 is 1.9763 and is around 1.98. So answer B. You see that? Answer B. Answer B. Answer B. So B is the correct answer. So that is the first problem. Now we continue on the second problem. You are given fund X accumulates at an interest rate of 8% compounded quarterly. Quarterly, that means they use a nominal rate. Please get used to the terminology. If the question say compounded quarterly, monthly, semi-annually, annually, or compounded 6 times a month, something like that, that means the question given you the nominal rate, not the effective rate. So fund X accumulates at an interest rate of 8% compounded quarterly. I'm going to write out very quickly. I have fund of X. Oh, what happened here? Oh, excuse me, it's a mess here. Okay, so here we have the first information give you fund of X. So fund X using the nominal rate, that is I'm gonna call I script X of quarterly. So that means that the money is compounded 4 times a month, 4 times a year, 4 times a year. So we have I to the top script 4 equal to 8%, and fund Y, you have I semi-annually, that means the money is compounded twice a year. So you have I with the script 2 and the top script of 2 equal to 6%. And the question said that at the end of 10 years, the total amount in two funds combined is 1,000. So first look at the money that fund X accumulates after 10 years. So we have 18. Hold up. So the total amount of two funds at the end of 10 years is, for X we have X is the principal. So at this time, because we're not investing only $1, so we need X at the front. So X time with after 10 years using nominal rate, so that is 1 plus 0.08 over 2 the whole thing to the powers of 0.08 over 4, because compounded quarterly, to the power of 4 times 10, that is 40, plus fund Y is Y times with 1 plus 0.06 over 2, the whole thing to the powers of 10 times 2, that is 20. You see that? So this is the total amount of two funds at the end of 10 years. And this is equal to 1,000. So this is the first equation. We can rewrite this at 1.x times with 1.02 to the powers of 40 plus y times 1.03 to the powers of 20. This is equal to 1,000. So that is the first formulas. And using the second formula, it said at the end of 5 years, the amount of fund X is try that in fund A. So after 5 years, we have the second formula, that is X times with 1 plus 0.08 over 4, the whole thing to the power is 5 years, so 5 times 4 is 20, equal to 2 times the amount of fund in Y, so that is Y times with 1 plus 0.06 over 2, the whole thing raised to the powers of 10. You see that? So this is the second equation. So here you have X times with 1.02 to the powers of 20 equal to 2 times with Y times 1.03 to the powers of 10. To the power of 10. To the power of 10. And the question asks for the total amount in two funds at the end of 2 years. Okay, so this is the second formulas. So our job is find X and Y. First, to find the total amount of fund after 2 years. So using these formulas, we have X. If we multiply both sides by 1.02 to the power of 20, we have X times with 1.02 to the powers of 40 equal to 2y times with 1.03 to the power of 10 times with 1.02 to the powers of 20. That means we multiply both sides by 1.02 to the power of 20. So now we use this one, we substitute into the first equation. So this is the first equation. Ctrl Z. This is the first equation, and this is the second equation. So we are going to substitute the second equation into the first equation. So we have, hold up, oh, excuse me, there's a mess here. So substitute 2 and 1. Substitute. Two into 1. We have an equation of simply y. So we have 2y times with 1.03 to the power 10 times with 1.02 to the powers of 20 plus y times 1.03 to the power 20 equal to 1000. And from here we would be able to find y. So y equal to 1000 divided by 2 times 1.03 to the power 10 times 1.02 to the power 20 plus 1.03 to the power 20. And the answer is 172 for B. 172.41 for B. And from here we would be able to find x. So x equal to 2 times 1.03 to the power 10 divided by 1.02 to the power 20. X should be equal to 311.86. Now we find the total amount of fund after 2 years is, we have x is 311.86 times with 1.02 to the powers of 8 plus y is 172.41 times with 1.03 to the powers of 2 times 2 is 4, and that's equal to, so 311.86 times 1.02 to the power of 8 plus 172.41 times 1.03 to the power of 4, that is 559.44. So that is the total amount of fund after 2 years. That is the total amount of fund after 2 years. So that is 559, which is 560. So the answer is A. So this is around 560. So the answer is A. Answer A. Answer A. So that is the second problem. Let's look at the third problem. Brooks and Robbie each open a new bank account at time 0. Brooks deposit 100 into his bank account, and Robbie deposit 50 into his account. Each account earn an annual effective discount rate of D. The amount of interest earned in Brooks' account during the 11th year is equal to X, and the amount of interest earned in Robbie's account during the 17 years is also equal to X. So here, they use an effective discount rate. So the accumulation function in this case, excuse me, it's a mess here. So here we have, I'm so sorry, it's a mess here. So here accumulation function is a of t equal to 1 minus d to the powers of negative t. That is the accumulation function. And the question say that the amount interest in Brooke account during 11 years. So Brooke account. So the amount of interest in Brooke's account during the 11 years is, we have the first equation, that is x equal to, so 11 year, the interest earned in 11 year would be the accumulated value at time 11 subtract the accumulated value at time 10, right? Time 10. So that's equal to, we have Brooke deposit 100, so 100 times with a of 11 minus 100 times with a of 10. So that's 100 times with a of 11 is 1 minus d to the powers of negative 11 minus 1 minus d to the powers of negative 10. And this equal to x. And the amount of interest earned in Robbie account during the 7 years is also x. So the amount of interest in Robbie's account during the 17 years is also x. So we have the second equation is x equal to, for Robbie he deposit 50, so that is 50 times with a of 17 minus a of 16, and that's equal to 50 times with 1 minus d to the powers of negative 17 minus 1 minus d to the powers of negative 16. So this is the second equation. So we are going to use these two equations to solve for x. So if you divide side by side, divide side by side, we have 1, because x over x is 1, so 1 equal to 100 over 50 is 2 times with here on the top we have 1 minus d to the power of 11, negative 11, minus 1 minus d to the power of negative 10 over 1 minus d to the power of negative 17 minus 1 minus d to the powers of negative 16. So that is the equation of similarly d. Now we are going to factor 1 minus d outside to cancel it. So we have 1 over 2. I'm going to move 2 to the other side to make it simple. So 1/2 equal to, on the top, if I bring 1 minus d to the power 10 outside, if I bring 1 minus d to the powers of 10 outside. So I have 1 minus d to the power of negative 10. And inside I have 1 minus d to the power of negative 1 minus 1 over, at the bottom I'm going to bring 1 minus d to the power of negative 16 outside, so 1 minus d to the power of negative 16 times with 1 minus d to the power of negative 1 minus 1. And you see here on the top and at the bottom we can cancel the factor 1 minus d to the negative 1 minus 1. So we have 1/2 equal to 1 minus d to the powers of negative 10 over 1 minus d to the powers of negative 16, and this equal to 1 minus d to the powers of 6, and from here we will be able to find 1 minus d. So 1 minus d equal to 1/2 to the power 1 over 6, 1/2 to the powers 1 over 6, and that's equal to, so that's equal to 0.890809. So from here we have 1 minus d, so we are going to construct x. So we either can use the first equation or the second equation. We have x equal to 100 times with 0.8909 to the powers of negative 11 minus 0.8909 to the powers of negative 10. So this equal to 388 point is around $38.88. So that is the answer, 38.88. So let's check here, 38.9, that is 38.9. So this is answer E. So that is answer E. Okay, let's do 2 more problems. Problem number 4. Which of the following are correct expression for d to the top group 360? The first one, 1 minus v to the 1 over 360. So here we are going to justify one by one. They give you 3 formulas and they ask you which formula is correct for d to the 360. We might have more than 1 correct formulas. So what we have to do, go and check one by one. So now we check the first formulas. The first formula, we know that v equal to 1 plus I to the power of negative 1. 1 minus d to the power 1 minus d to the powers of v equal to 1 minus d, and this equal to 1 minus d to the top group of 360 over 360 to the powers of 360. So from here we are going to find d of 360 using v. So we have v to the powers 1 over 360 equal to 1 minus d to the power of 360 in the top group over 360 over, by the way, 360 on the top group here is not the exponent. So to make sure you're not going to get confused. So here we have leading to 1 minus v to the 1 over 360 is equal to d to the top script of 360 over 360. So this is completely different from d to the top script 360. So leading to this is I is incorrect. Now we go to the second formula. Check the second formula. The second formulas, we are going to use the nominal, the relation of nominal interest rate and nominal discount rate. Here we have I to the 12, so I'm going to write down the formulas of AT. So A of t equal to, here since we involving d to the 360 and I to the 12, so this is 1 plus I to the 12 over 12, the whole thing to the power of 12t, and this is equal to 1 minus d to the 360 on the top script over 360 to the power of negative 360 t. So from here we have 1 plus I to the 12 top script over 12, the whole thing to the powers of 12, equal to 1 minus d to the 360 over 360 to the powers of negative 360. So this is the equation making connection between I nominal rate compounded monthly and discount rate compounded 360 times a year. Now we are going to solve for the nominal rate of interest compounded, the nominal rate of discount compounded 360 times a year. So we have 1 minus d to the 360 in the top group over 360 equal to 1 plus I to the top group of 12 over 12 raised to the powers of 12 divided by negative of 360. So here we have these formulas, and we have d to the top group of 360 would be equal to 360 times with 1 minus 1 plus I to the top group of 12 over 12 over 12, the whole thing raised to the powers of negative 1 over 30, negative 1 over 30. So this is the formulas between d of 360, d to the top group 360 and I to the top group of 12, and we compare with the formula here. We see that they are the same, right? They are the same, because if you factor it out, that becomes 360 minus 360 times with 1 plus I to the top group of 12 over 12, the whole thing to the power of negative 1 over 30. Negative 1 over 30. So if you compare with the formulas, that is negative 1 over, hold up, It's still not the same. It's still not the same because the powers here is nib1 over 30, not nib30. So this formula is not correct. So not correct, not correct. Now we check the last formula. Check the last one. Check the last one. So the last one, make connection of d to the 360 with I to the 360. So we have a formula that is 1 minus d to the 360 in the top script over 360 over 360 raised to nib 1 equal to 1 plus I to the top group of 360 over 360, the whole thing raised to the powers 1, no powers, raised to the powers 1, raised to the powers 1. So from here we are going to make connection, we are going to solve for d of 360. So 1 minus d to the 360 in the top group over 360 equal to 1 over 1 plus I to the top group of 360 over 360, and leading to, now we are going to solve for d of 360. So d to the top group of 360 equal to 1 minus that is 360 times with 360 times with 1 minus 1 over 1 plus I to the top group of 360 over 360, the whole thing times 360. So this is the connection between d to the 360 to 1 to the 360 in the top groups, and we compare, we see there are so here we also can divide 360 1 over and this equal to 360 times with, let we divide some more, so that become I to the top group of 360 over 360 over 1 plus I to the top group of 360 over 360, and this equal to I 360 with 360 are cancel out, so we have I to the 360 on the top group over 1 plus I to the top group of 360 over 360. So now we are going to divide the top and the bottom by I to the top group 360. So the top we have 1 over I to the top group of 360 plus 1 over 360. So this is the final formulas. This is the final formulas. And we will compare this one with what we have here, and they are the same. They are the same. So the last one is the correct answer, and only the last one. So Only 3. Only 3. So D is the answer. Only 3. Okay, we do one more problem and we're done for today. At time t equals to 0, $1 is invested in each of fund X and Y. Fund X accumulates at a force of interest rate delta t is t squared over k, and fund Y accumulates at a nominal rate of discount 8% per annum, convertible semi-annually. At time t equals to 5, the accumulated value in fund X equal to fund Y. So fund X at time t, we have at time t, we have for fund X. We need to find A of t first, so integrate from integrate. So at time t equal to 5, fund Y, we have A of 5 equal to 1 minus 0.08, because this is discount rate convertible semi-annually, so that is D to the top group 2. So 1 minus 0.08 over 2, the whole thing to the powers of 2 times 5 is 10. And that's equal to 1 minus 0.04 to the powers, this is to the power of -10. So to the power of -10, you got that is 1.504. Now we work on fund X. So first we need to find the accumulation function. So we have integrate from 0 to t of delta r dr equal to integrate from 0 to t of r squared over k dr, and that equal to rq over 3k, and this one is calculated from r equal to r equal. So r go from 0 to t, up 0 to 5, 0 to t, 0 to t, 0 to t, and I'm very sorry about that. This is a little bit mess. So, and this is r equal to 0. So this is equal to tq over 3k, tq over 3k. So that is how we find the integrate. So now we have A of t equal to e to the power of tq over 3k, tq over 3k. And now we have A of 5 will be equal to e to the powers of 125 over 3k. 5q is 125 over k. And because these two funds have the same accumulated value at time t5, so this is equal to 1.504. So from here we will be able to find k equal to 125 divided by natural log of 1.504, and that's equal to 306 what over 3k. So over, let's say over 3k, so this is divided by 3, so this equal to divide by 3. 102.09. So the answer is B. The answer is B. The answer is B. Alright, thank you so much for watching this video. It is a little bit long because I combined the whole section. One section is like 100 is go up to, I guess I have finished up to 80 pages from the book in one video of 2 hours. Thank you so much for watching, and see you guys on Friday. I have a video about statistics. Alright, thank you so much, and see you next time. Bye bye.